Hello and welcome to chapter 5, antenna and wave propagation. Okay, so as you would know, in this chapter we are learning about antenna and some of the wave propagation and how it transfers through the air using antenna. All right, so first things first is near and far fields. Okay, it is a boundary region of electromagnetic radiation that emits or emanate from an antenna. So it's a radiation that comes out from the antenna lah, basically. So the region located less than one wavelength from the source is called the near field, and the region extending farther than 10 wavelengths away from the source is called the far field. Alright, as you see from the name itself, near field is nearer and far is further from the source. Okay, so near field pattern that is close to the antenna and sometimes called the induction field or Fresnel zone. So during one of the half cycle, power is radiated from the antenna, where some of the power is stored temporarily in the near field, and during the second half of the cycle, power in the near field is returned to the antenna. So this is defined as the area within the distance by d square over wavelength. Okay, the antenna diameter squared over wavelength. Electric and magnetic field is distinct, separate and different, distinguishable, and one of the application for these things is an RFID. Okay, RFID. What is RFID? Is the key card you see in the hotels, in the apartment, in the parking space, all of those things lah, using RFID. Okay, far field is a field pattern that is at great distance, sometimes called the radiation field or the Fraunhofer zone. The power that reaches the far field continues to radiate outwards and it is never returned back to the antenna. Therefore, antenna radiation patterns are generally given for the far field. Alright, antenna directivity. It is the measure of the concentration of an antenna's radiation pattern in a particular direction, and it is expressed in dB, decibels. The higher the directivity, the more concentration and focus is the beam radiated by the antenna. Okay, higher directivity also means that the beam will travel further. An antenna that radiates equally well in all directions would be omnidirectional and have a directivity of 1 or 0 dB. A high directivity is not always better. For example, many applications like mobile devices require omnidirectional antennas and thus require antennas with a low or no directivity. High directivity antennas are used in permanent installations such as satellite television, wireless backhaul, as they need to transmit and receive information over longer distance in a particular direction. So that's why, as you can see in any of the antenna, the most common one is Astro punya antenna lah, where it is more focused and it use high directivity antennas so that it will capture signals or waves from a specific direction in from the satellite. Okay, so that is high directivity antennas. Right, for antenna gain, it is the product of directivity and efficiency, where the efficiency account for the losses on the antenna such as manufacturing faults, surface coating losses, dielectric resistance, VSWR from the previous chapter, or any other factor. In a transmitting antenna, the gain describes how well the antenna converts input power into radio wave headed in a specified direction. In a receiving antenna, the gain describes how well the antenna converts radio wave arriving from the specified direction into electrical power, directive gain and power gain. So these two are the different type of gains that you will see in this topic. So for directive gain, it is the ability of an antenna receive signal from one direction while rejecting interfering signals coming from a different direction. The ratio of the power density radiated in a particular direction to the power density radiated to the same point by a reference antenna, assuming both antennas are radiating the same amount of power. So directive gain is usually on the receiving end of the machine, okay, and it will only accept the signals coming from a certain direction, but it will also reject signals from different direction. Okay, that's why the satellite or antenna is currently in our generation is much more specific. Okay, so this is the equation for directive gain, which is equal to D equal to P over PRF, where P is the power density at some point and P ref is the power density at the same point with a reference antenna. Okay, the P and the P reference. The other one is the power gain, okay, or just simply gain. It is a unitless measure that combines an antenna efficiency and directivity. The same as directive gain, except that the total power fed to the antenna is used. It is assumed that the given antenna and the reference antenna have the same input power, that the reference antenna is lossless, where N efficiency is equal to 100%. If an antenna is lossless, it radiates 100% of its input power and the power gain is equal to directive gain. And the power gain of antennas is in decibel. So how do we transmit antenna gain? In a practical communication system, it is important to know the signal strength at the receiver input. Okay, at the receiver input depends on the transmitter power, the distance from the transmitter to the receiver, but also upon the transmitting and receiving antennas. The two important antenna characteristics are the gain of the transmitting antenna and the effective area of the receiving one. And antennas are said to have gain in those directions in which most power is. So let us see on the receiving antenna gain. A receiving antenna absorbs some of the energy that passes it, and a larger antenna receives more power than a smaller antenna. It is in relation to the surface area lah, biasalah. If it's big, it receive more. It is small, it will receive less. Okay, and receiving antennas are considered to have gain just as transmitting antennas do. The power extracted from the receiving antenna is a function of its physical size and its gain. Do take note that the power radiated from the antenna can never exceed the input power. Okay, and therefore the antenna does not actually amplify the input power. An antenna simply concentrates its radiated power in a particular direction. So what this means is the antenna itself does not increase the power or the signal strength of a certain signal. It is only concentrating the signal so that it will radiate in a proper direction, okay, in a particular direction.